Hi chickens! So here we have a system of equations and we need to solve them using elimination. You know you need to solve them using elimination because none of the coefficients of x or y are 1, so they're not by themselves. So the first thing we need to do is we need to try and get the coefficients of x being the same or the coefficients of y being the same. To do that, we're only allowed to use multiplication or division. Now it doesn't matter which one you choose, it's up to you. I'm going to go with x, so I'm going to multiply equation 1 by 3. And I'm going to rewrite it. So negative 3x times 3 is negative 9x. Negative 6y times 3 is negative 18y. And negative 3 times 3 is negative 9. And I'm also going to rewrite the second equation underneath. So then we can perform our elimination either by subtracting or adding. Okay, so we need now to decide, are we going to add or are we going to subtract? How you do that is you have a look at the signs. Now the same sign, these two are the same here, the same sign means you're going to subtract. Now you don't really need to remember that because you can work it out. So negative 9, if I was to add minus 9, I'd end up with negative 18. And what we want is 0. So in this case, addition wouldn't work. So I know I have to subtract the equation, which means I'm subtracting everything in equation 2 from equation 1. So let's do that. Negative 9x minus negative 9x, so they're both negatives, that becomes a plus, is 0. Negative 18y minus negative 18y becomes a plus again, it's also 0. And we get 0 again. So here we now know we have a special case. When the left-hand side equals the right-hand side, we have infinitely many solutions. Now what does that mean? That means that they actually form the same line. If we were to graph this on a coordinate plane, the first equation would be one line. Let me do that in a different color for you. So that would be the line, and then the second equation would just be the same line over the top. So they're exactly the same line, which means at every single point on that line, it's considered an intersection. Therefore, it's a solution. So we have infinitely many solutions.